All right, so here we're going to do another example of solving a nonlinear system of equations. We could use elimination, that is, I could multiply the first equation by -2, because then we would have -2x squared plus 2x squared is 0, right? But I prefer substitution. I think it's just straightforward. So what I could do is either solve this equation for x squared and plug it into here, or I could solve this equation for y squared and plug it into here. I'm going to solve for y squared. I'm going to solve for x squared. So this first equation, when I subtract y squared from both sides, we get x squared equals 16 minus y squared. Now that I know what x squared is equal to in the first equation, I substitute it into the second equation. In other words, in this equation, wherever there's an x squared, I plug this in. So we get 2 times x squared, but for x squared, I plug in 16 minus y squared. Plus 3y squared equals 36. And now we just solve this. Distributing, we get 32 minus 2y squared plus 3y squared equals 36. Adding these, we get y squared plus 32 equals 36. When I subtract 32 from both sides, 36 minus 32 is 4. And when I take the square root, don't forget when you take the square root of a square, you get a positive and a negative. The square root of 4 is 2. So we get y is positive and -2. So now we got to find out, well, when y is 2, what is x equal to? Well, again, let me just write this explicitly. One answer is y is 2. The other answer is y is -2. So when y is 2, what is x? Well, again, we plug y as 2 into either equation. I'm going to plug it into the first equation. So when I plug in 2 for y, we get x squared plus 2 squared equals 16. So x squared plus 4 equals 16. Subtract 4 from both sides and we get x squared equals 16 minus 4 is 12. Take the square root. Don't forget your plus and minus. When you take the square root, x is plus and minus the square root of 12. 12 is 4 times 3. The square root of 4 is 2. So x is plus and minus 2 times the square root of 3. So notice, when y was 2, so what I did here is y equals 2. I plugged it in. When y is 2, we get 2x values. So that means one answer is x is positive 2 root 3 when y is 2. When x is negative 2 root 3, y is also 2. So there's 2 points of intersection. Now we could write this as one clean answer of plus and minus 2 root 3 comma 2. So this is another way of writing both of those answers. So here's 2 solutions. Now we got to find, well, what's another solution when we get another answer when y is -2? Let me do this. So when y is -2, we're going to get the same thing, because when I square -2, we get positive 4. X squared plus -2 squared equals 16. Just plugging that in. -2 times -2 is 4. Subtract, we get 12. You get the same thing. So when I take the square root, I get x's again, plus and minus 2 root 3. So this means when x is 2 plus, I'm going to write it like this, when x is positive or -2 root 3, y is -2. So there's 4 answers here. 2 root 3, 2. negative 2 root 3, 2, 2 root 3, negative 2, and negative 2 root 3, negative 2. How does this relate to what we did here? Well, this equation is a circle centered at the origin with a radius of 4. This is an ellipse, and if I graph that ellipse, you're going to get a graph kind of like this. It's not a very good graph, but anyways, here's 2 solutions and here's the other 2 solutions. So one answer, when x is 2 root 3, you get positive and negative root 2. 2 root 3 positive 2, 2 root 3 negative 2. The other answer is negative 2 root 3 when x is negative 2 root 3. Yeah, I didn't do a very good job graphing that. But then it's going to, these 2 solutions are negative 2 root 3, and then x is 2, y is 2, and y is negative 2. So these are the 4 points that correspond to these 2 and these 2 points. Again, what we're finding is the points where these 2 graphs intersect. All right, so that's another example of solving a system of nonlinear equations.